This lesson will cover the following topics. Engine operation. The cylinder block. Petrol or diesel internal combustion engines convert calorific energy into mechanical energy during a four-stroke cycle. Whatever the engine type, the crankshaft must rotate 2 turns, i.e. 720 degrees, to perform one complete cycle. A stroke is completed in 1/2 turn of the crankshaft, 180 degrees. In order to run, the engine needs an explosive mixture consisting of petrol or diesel and oxygen present in the air. The engine operates according to the following cycle. Intake of the air-fuel mixture, induction. Compression. Ignition of the mixture. Combustion, power stroke. And exhaust. In a diesel engine, combustion of the mixture is by simple compression followed by an injection of diesel fuel. By contrast, the ignition for petrol engines is via a spark. Diesel engines are known as self-ignition engines. Engine operation takes place according to the following cycle. Intake, induction. Compression. Injection of diesel fuel. Combustion, power stroke. And exhaust. First, let's take a look at the first phase of the cycle, the intake, induction stroke. The piston descent creates a vacuum which draws in the mixture or the air through the open inlet valve. During this stroke, the exhaust valve is closed. The piston reaches the bottom dead center and the inlet valve closes. The second stroke is the compression. The 2 valves are closed. The piston ascends to the top dead center. The mixture is then compressed inside the combustion chamber. The compressed mixture heats up. The third stroke is the combustion, power stroke phase. The 2 valves are still closed. The piston is at top dead center. The mixture ignites. The ignition pushes the piston downwards. This is the power stroke. The calorific energy is converted into mechanical energy. The 4-stroke cycle is completed by the exhaust stroke. Once the piston has reached the bottom dead center, the exhaust valve opens. The piston ascends and drives out the burnt gases. The inlet valve is still closed. When the piston returns to the top dead center, the exhaust valve closes and the cycle starts again. In a 4-cylinder engine, the cycles of intake, induction, compression, combustion power stroke and exhaust are sequenced over each cylinder. The timing synchronizes the movement of the camshafts and the crankshaft. The pistons are displaced sequentially, assuring continuity of the crankshaft rotation. The opening and closing of the valves is synchronized in relation to the movement of the pistons. The points of opening and closing of the valves in the 4-stroke cycle seen previously are theoretical. In reality, the opening and closing of the valves is sequenced to optimize engine performance. The timing diagram represents the valve opening advance values and the valve closing retard values. In this section, we covered the following points. Internal combustion engines convert calorific energy into mechanical energy. This is the 4-stroke cycle. In a diesel engine, combustion of the mixture is done by simple compression, followed by an injection of diesel fuel. The mixture, or the air, enters the cylinder via the inlet valve. With the valves closed, the piston ascends and compresses the mixture inside the combustion chamber. During combustion, the compressed mixture ignites. The calorific energy is converted into mechanical energy. The four-stroke cycle is completed by the exhaust stroke. The cycles are sequenced over each cylinder. The pistons are displaced sequentially, assuring continuity of the crankshaft rotation. The timing diagram represents the valve opening advance values and the valve closing retard values. The engine identification plate is stamped, riveted or bonded to the engine. It is not always accessible, but more often a self-adhesive label is located on the timing cover, which indicates the engine type. To find out the exact location of the engine identification plate, refer to the Component Workshop Repair Manual or to Dialogis. Here is a description of an engine identification plate. First of all, we are going to specify the type of engine, which here is a G9T. The first character on the left relates to the engine range. In our example, the letter G corresponds to an engine with a cast cylinder block, cylinder liners, and an aluminium cylinder head. The second character indicates the type of cylinder head. In the example, figure 9 corresponds to a cylinder head on a direct injection diesel engine. Finally, the last character corresponds to the cubic capacity. For example, the letter T corresponds to a cubic capacity of between 2,151 and 2,300 cc. The remaining characters on the identification plate give other information. The letter L corresponds to the engine approval letter. The figure 7 indicates the identity of Renault SAS. The number 20 corresponds to the engine suffix. This number relates to the assembled engine part number reference. The letter C relates to the engine production plant. Lastly, the next number relates to the engine fabrication number. The engines in the Renault range are equipped with 4 or 6-cylinder cylinder blocks. The cylinder blocks are usually configured as in-line or V configuration. On a 6-cylinder configuration, the front and rear banks can be distinguished. In this section, we covered the following points. The engine identification plate is found on the engine. A self-adhesive label on the timing cover indicates the type of engine. The engine plate indicates the engine type and suffix, as well as its fabrication number. The engines in the Renault range are equipped with 4 or 6-cylinder cylinder blocks.